Hi, we are from Group 4 and today we would like to talk about Fourier series and its application. Our group consists of 3 people, with me as the leader, Ahmad Shahiran, and the group members, Muhammad Aiman and one Muhammad Jumal Hij.
Hi, my name is Muhammad Iman and I will be explaining for task 1. Question 1. Find any even function, sketch the function for several periods and determine the Fourier series of fx. So this is the graph that has been plotted based on the function that has been given, and as we can see, the graph of an even function is symmetric about the y-axis. So to determine the Fourier series of an even function, we need to find the value of EO and EN. So firstly, we need to find the value of L, which is 2 pi, and then we will put in the value in the equation of AO and EN. So based on the calculation that we have made, AO we will get the value of negative pi over 2. Then the value of an is 4 over n sine n pi over 2 minus 4 over pi n squared cos n pi plus 4 over pi n squared cos n pi over 2. Then the Fourier series of even function is negative pi over 4 plus 4 over n sine n pi over 2 minus 4 pi n squared cos n pi plus 4 pi n squared cos n pi over 2 times cos nx over 2. Question 2. Find any odd function, sketch the function for several periods and determine the Fourier series of fx. So this is the graph of an odd function, and as you can see, it is symmetric about the origin. To determine the Fourier series of an odd function, firstly we need to know the L of the graph. So it is L is equal to pi, then we will put the value of pi into the equation of Bn, and lastly we will get the value of Bn is negative 2 over n pi times cos n pi minus 1. Then we will put the value of Bn into the Fourier series equation for odd function, and we will get the value of negative 2 n pi cos n pi minus 1 times sin nx. Question 3. Find any neither even nor odd function, sketch the function for several periods and determine the Fourier series of fx. This is the graph for even nor odd function, and we can see that it is not symmetry about the y-axis or the origin. So to determine the Fourier series, firstly we need to know the L for the graph. So the L for the graph is 1. Then we will put the value of 1 into the equation of AO, EN and also Bn. Then we will get the value of AO is 11 over 2. Value of EN is 1 over n pi squared minus cos n pi over n pi squared. Then the value of Bn is equal to 3 cos n pi over n pi minus 2 cos n pi over n pi minus 4 over n pi. Then we put the value of An, AO and also Bn.
For task 2, I am Ahmad Shahiran and I will be explaining it. For task 2, we will need to expand the function by sketching and give the expansion Fourier series in a cosine series, a sine series, and a Fourier series. Okay, so for task 2, the function that we had chosen is as shown. For the period is 4 and the interval is in between negative 6 until 6. For cosine series, the graph is as shown in the picture. The red line is the reflection from the original line, which is the blue and the green line. And as you can see, the red line is in between -6 to 6, which is the interval for this function. For cosine series, to get the function, we will first need to determine the L. L that we get here is 2, then we put it into the equation as shown at the picture. So the answer for the cosine series is fx equal to 1 plus -4 over n pi square cos n pi minus 1 cos n pi x over 2. Next, we have the sine series graph. As we can see, the reflection, which is the red line, is a bit different from the cosine series graph. To determine the sine series functions, we just repeat the same method as the cosine series, which is determine the L first, and then we just put it into the equation as shown at the picture. So the answer for the sine series is fx equal to -4 over n pi cos n pi minus 4 over n pi sin n pi times sin n pi x over 2. For the Fourier series graph, the red line is the exact same copy of the original line. For the Fourier series function, the method will differ from the cosine series and the sine series function. As you can see, the final answer is fx equal to 1 over 2, 2 over n pi square times cos n pi minus 1 times cos n pi x over 2 plus -2 over n pi times cos n pi times sin n pi x over 2. As you can see, Fourier series is used to describe a periodic signal in terms of cosine and sine wave. In other words, it allows us to model any arbitrary periodic signal with a combination of sines and cosines. That's why we use the cosine and the sines to determine the Fourier series.
Next, for harmonic analysis, even though an output function in experimental operations is periodic, it is frequently stated as a set reading, making direct integration to get the relevant Fourier coefficient impossible. As a result, harmonic analysis and approximation is employed. The concept of definite integral is equivalent to finding the area under the curve is applied in the approximation. As you can see, usually the table given will be like this for this part. But before we can settle this, we must understand what we need to find first. Here, the formula that we can use to find A0, AN and BN. At the bottom, the formula for C0, Cn and alpha n. For final answer, it must be written in standard form, which C0 plus C1 sin x plus alpha 1 plus C2 sin 2x plus alpha 2 and so on. Here, the example of the set of data. This question requires calculations in 3 decimal places. Find the Fourier series function x in the standard form up to and including the second harmonic. YR cos XR and YR sin 2XR is given, where we can use it to find A1 and B2. To avoid confusion while doing calculation, the answer method is arranged to A0, C0, next A1, B1, C1, and then after that calculate for A2, B2, C2, and finally for alpha 1 and 2. By using the correct formula, the answer as shown. A0 need to be found in order to get C0. A1 and B1 must be settled out first to get C1 by using formula, and finally same as before for A2, B2 and C2, the answer as shown. For alpha 1, by using formula, the answer will be -19.251 degree. Here, the positive y-axis and negative x-axis appear, which the value can be concluded at quadrant 2. Because of that, 180 degree will minus 19.251, and the final answer for alpha 1 is 160.749 degree. For alpha 2, the final answer is 42.473 degree. Here, there is no need to add or minus the value because it have positive y-axis and positive x-axis, which the value is at quadrant 1. For final answer, standard form was used as the question asks, up to and until the second harmonic. I think that's all from us. Thank you.